So thank you all for coming. Welcome to Datapalooza. I am Al Wenholtz. I'm the research data librarian here, and I'll be facilitating the program. We have some great speakers that we're really excited about. And for those of us joining us via Zoom, we would ask for you to stay muted during the presentations. When we get to the Q&A, feel free to put your questions or comments into chat. And if you have any technical difficulties, please reach out to Steph Crowell, who's here in the room with us. I'd also like to thank and introduce the rest of the Datapalooza team. Pam Martin, who's joining us remotely, and Steph Crowell, do you mind waving? They're the science librarian, and Erica, our scholarly communication librarian, and Pamela Martin is our engineering librarian. And feel free to reach out to them at any point as well. They're great to work with. I'd also like to thank you for being a hardworking, dedicated team and pulling this event together. I'd also like to take a moment to acknowledge that as a land grant institution, the Utah State University campuses and centers reside and operate on the territories of the 8 tribes of Utah who have been living, working, and residing on this land from time immemorial. These tribes are the Confederated Tribes of the Goshute Indians, the Navajo Nation, the Ute Indian Tribe, the Northwestern Band of Shoshone, the Paiute Indian Tribe of Utah, the San Juan Southern Paiute, the Skull Valley Band of Goshute, and the White Mesa Band of Ute Mountain Ute. We acknowledge these lands carry the stories of these nations and their struggles for survival and identity. We recognize elders past and present as peoples who have cared for and continue to care for the land. In offering this land acknowledgement, we affirm Indigenous self-governance, history, experiences, and resiliency of the Native people who are still here today. So to get started, we'd really like to learn a little bit about all of you, those in the room and those of us joining via Zoom. In order to do this, I'm going to ask you to take out a smartphone or a computer and open up a browser. So once you have the browser open, follow the instructions that we're putting up here. It's menti, menti.com, and enter the numbers. So
1488070.
Menti.com. So, and I'm going to turn it over to Erica to ask some questions.
Just give everyone another minute to join. 9 people who've joined the room. So again, you can do this on your smartphone or in another browser. Here on your computer, just go to menti.com and enter 81488070. Then you should see the screen. First question here, which is, what department or program are you? Now, I do want to take the time to say this is anonymous, so no one is going to see respond to these questions. And it looks like we've got a really good mix of people here today. Fantastic. All right. Oh, and we still got some answers coming in, more people. Yes, we've got people from all over the university today. So you're all using data and all interested in data management. I'm so glad you joined us today. All right, I'll give you, let's say maybe 10 more seconds. All right, let's close voting on this one and go to the next slide. Data set would you want to work with on the file type? We've got CSV, we've got Oh, we've got 2 intrepid people who are interested in working with PDFs. You're very brave. All right. Third question, how confident are you in your understanding of data management? Would you call yourself a total noob or are you a pro? So this is averaging everybody's answers, so we're looking okay. All right, about a 3.1 on a scale of 1 to 5. That's not too bad. Hopefully we can bump that score up a bit after today. And last question, what's something you hope we talk about today? People are taking a little bit more time to think about this one. Data. I can promise you we will talk about data. Organization, sharing data. Not even sure what you mean by data management. Okay, we will help with that, I promise. Oh, lots of stuff here. Okay, fantastic. Shortcuts. Amazing. All right. Thank you so much for all of your responses. We're going to jump into the presentation now. We will be back at the end with some wrap-up questions. So feel free to leave this open on your phone or in your browser, and you can join us again at the end.
So it seems like that mic is having a little bit of issues. So I'm going to go ahead and hand you this mic. But thanks so much. And first up, we have Professor Jeff Horsberg giving us an introduction to data management. Dr. Horsberg is Associate Professor in Civil and Environmental Engineering and Associate Director of the Utah Water Research Laboratory. His research is focused on hydroinformatics, observing systems and observation systems and sensor networks, data models, and developing cyber infrastructure supporting environmental observations, including the HydroShare data repository.
Cool, thank you. All right, hopefully that's going to be in a place that it works. Thank you. Well, I'm happy to be here with you today, and I'm excited to talk to you about a topic that is near and dear to my heart. I'm probably one of the world's biggest data geeks. Proud to be a data geek. So hopefully I have something that I will say today that's useful to you. Based on the meter from 0 to 5, maybe some of the things that I'm going to say you already know, and that's great. It'll be a great review, and some of you may have been hearing some of these things for the first time. That's also great. Definitely no judgment here. So I want to plant an idea at the very beginning of my presentation. Many of you may be working on research. Many of you may go on to an illustrious career of consulting or working for a government agency. I want to plant the idea that data are first-class products of research. And what I mean by that is we often think that, you know, the papers we publish or the other things that we do are the primary products, and data tend to be a byproduct that we deal with, and then we summarize in our papers, we publish the papers. But I want to submit to you that data are first-class projects that we should treat in that way. And there's a lot of people that have been thinking this way for a long time, so it's not just me. One of these groups is the Force 11 Data Citation Synthesis Group. These 3 points come from a list, a longer list, but I want to highlight these because they draw out, number one, data should be considered legitimate citable products of research. We just talked about that. But data citation should facilitate giving scholarly credit and normative and legal attribution to all contributors to the data. And then number three, in scholarly literature, we're used to citing people's papers, right? If they're not our words, we need to tell people where we got those words. But in the same way, if we're using other people's data, we should be citing those data in the same way we're citing other people's writing. Now, data sharing requirements. Is it okay if I hide these Zoom controls? Okay. Great. Hopefully that little shadow thing will go away here in just a second. Okay. So data sharing requirements, some of you may know already, but how many of you are working on a federally funded research grant? Anybody? Yeah, so most federally funded research grants these days actually require that you share your data. It's a contingency of actually receiving the funding. Most proposals that are going in these days require a data management plan that tells the funding agency how you're going to do that. How many of you have submitted a paper to a scholarly journal and had them say, we'll publish your paper when you've shared your data? Yeah, so that's also starting to happen a lot more. And you may be surprised to find how broadly data is defined when it comes to these two instances. Of course, it's data used to generate or be displayed in the figures, the graphs, the plots, whatever is in your paper, but it may include code, computer software, other products that you're generating as part of your research. So it may be surprising to you that how broadly some of these agencies and organizations define data. Okay. And there's a lot of writing that's starting to come out about people saying, well, wait a second, do you just expect me to give away all of my data? And it used to be that we saw a lot of things like you get to the end of the paper and you might see something that says like data available by contacting the author. And you call up the author if you can, or you send them an email and maybe you get the data, maybe you don't get the data, but the days of that are, I would say, are pretty much over. And the thinking is really trending towards when you publish a research paper, you're also simultaneously publishing the data. The data needs to support your work. It needs to be available. And the readers of your article have equal rights to see both the words and the numbers. They're inseparable. So those are not my words. Those are the words from this paper right here. But we're seeing this more and more in the scientific community. So you can go on the web and you can search for the scientific process and you can find any number of images like this that represent the scientific process. But I would also submit to you that communicating and sharing data is an essential component of this process. And you might even ask, if our science is not reproducible because we haven't shared the data, have we closed the loop? Have we completed the process? So how are we doing? This figure is taken from a paper that was written by a group at the Water Research Lab a few years ago. It was led by Jim Staggy, who was a postdoc at the Water Lab. They pulled 360 papers from these 6 water resources journals in 2017. So these papers were all published in 2017. Out of the 360 papers, they tried to reproduce the results based on the artifacts that were linked to the papers. And this number right here represents the number of papers out of those 360 papers. So 4 out of 360 is how many papers they could actually reproduce the results given the artifacts that were pointed to in the paper. So you can see some of the reasons why they were unable to either access the data or why they couldn't replicate the work, but that's not very good, right? And that's part of the reason why we have trust issues with science, because the data are not available, or there's no instructions for how to use the data, or the code that goes with the data are not available. And there's a lot of reasons why it's really hard to replicate and reproduce other people's work. Which brings us to Data Management 101. So I'm going to talk today about some simple guidelines to improve your data management. And there's a lot of benefits here. So improvement to your data organization, that's going to help you do your analysis. Making data sharing and publication easier, because you're likely going to have to share the data at the end of the process if you want to publish your papers. Improving the reproducibility that we just talked about, improving the capacity for other people to reuse the data. And then it's also going to help facilitate the compliance with funding sources and publishers. I'm not going to take any credit for the ideas that I'm going to present to you in the next, say, 15 minutes, because most of them come from this paper right here. 2009, and you might be going, wow, that's like a lifetime ago, 2009. It's an oldie, but a goodie, and it's also sort of cross-discipline. I'm an engineer, so a lot of the things that apply to me may not apply to you, but the principles that are in this paper are really pretty broadly applicable. Okay, so number 1, don't mess with the raw data. However you're collecting the data, however you're recording the data, keep a copy of that raw data, the original data that you produce, with all of its bumps and warts, as the paper says. Because when you make corrections, you could change something that was actually correct. You could make mistakes while correcting other mistakes. And so for us, we collect a lot of sensor data in streams and lakes and rivers, and they come in like in this top panel, there's all sorts of errors in the data, and we have to go back and remove periods like when the sensors were frozen in the ice or buried in sediment to make the data usable. But we often have to look back at the original record to make sure that we did things right. And we script that procedure using code to make sure that at any time we can go back and reproduce that in a way that anybody else could also reproduce it. So if you can, script it. I realize not everybody's collecting sensor data, and scripting doesn't make sense in your context, but that's a way that you can make things reproducible. So number 2, use descriptive file names. Now, if you look at my figure here, I'm just going to guess that every single person in this room and online in our Zoom has a folder on their computer, at least one folder on their computer that looks like this, right? So you begin your study, you're trying some things out, you got your test data file, and then you say, oh, I got to test this. So junk 1, junk 2, junk 3, and then you get serious, right? This is my stream data. I'm going to use this to generate my plot. Well, you're trying something else out and that doesn't work. So then you got stream data 2, stream data modified, stream data final, final, and then stream data use this one, right? So this is not a good system. Use only plain ASCII characters and avoid spaces, because if you're sharing files with somebody who's working on Linux or another file system, your file names might not work on their system if you're using special characters or spaces. Be brief with your file names, but descriptive of content. This might not even be so bad if you just put a README file in there that says, okay, junk 1, junk 2, and junk whatever are in there because I did this, and I saved those files because I might want them later because of this. And then this file has the actual data. Use that one if you need to regenerate figure 7 in the paper, right? So a README file goes a long way. Okay, a lot of people work with tabular data. It's one of the most common data types a lot of us use. Use descriptive headers in files and tables. So if somebody hands you a data file that's in a table, you might be really lucky to look at it and say, okay, I get what the date column means, an ID, but that's probably some kind of identifier. Location, well, maybe that's some sort of identifier for, so you can sort of understand some of these column names. But when you get down to this other table and you're like D18.0 and D2, I have no idea what those mean, right? So immediately I'm either sending an email or I'm on the phone with somebody asking what those mean. So if you can instead, at the beginning of your file, define what all of those columns mean, define what the units are, define the type of information that's in those columns, then the metadata go with the data. You save yourself a whole bunch of phone calls and emails. You don't have to answer all those questions because you've already preempted most of those questions by including the metadata in the data file that goes together. And there's a whole bunch of best practices for tabular data, things like each row should have a single observation. Each column should represent a single variable or attribute. Don't mix things up in columns. Every cell should have a single value. Don't try and overload cells with a bunch of information separated by commas. That's not a great data structure. Don't mix data types within columns, because when you open it in a piece of software, you're not sure how that software is going to handle that. And then use standard formats. Like, all of these are great practices, and there's a link down here to a paper that all of these tabular data practices came from. So there's a lot of things that you can use to standardize your data in ways that people are expecting, and also for you to give them information about your data to make sure that they can interpret and understand it if they are trying to reuse your data. Okay, number 4, archive data in non-proprietary formats. So this may be a really crazy thing to say, but Microsoft Excel is widely available and used now. It was when I was a student in my undergraduate degree, which was a long time ago. What about in 10 years? What about in 20 years? This is more of a problem with like proprietary data collection platforms. Some GPS systems, sensor systems produce specific files that have to be read by software that's produced by a particular manufacturer. So you have to ask yourself, how many other software programs can open the file that your data resides in And will your data disappear if that file format or software becomes obsolete? If no one can find the software to open your data are effectively dead. Okay. So then the next obvious question is, well, what format should I use? Store the file in a format that can be used by many different software programs. So you had the question before about what format do you want to use? A lot of people were voting for CSV. There's a reason for that, because CSV has been around forever. It probably will be around forever because it's easy to use. Most software programs know how to open it. But there are some communities, scientific communities, where there are standard file formats that everybody uses. They're accepted by the community, and you should consider using those formats because you don't want to be the odd person out. You should also consider not just the format of the file, but also the syntax, how you're structuring things inside of the file, and also the semantics, the language of the things that you're putting in the columns in your table. You want to be using names that are recognizable and language that's recognizable to people who might see your data. Number 5, consider data entry. So I think this is probably a generalization that can be made. All data collection involves some data entry, and that is true probably whether you're sitting out making observations of birds flying by or whatever and writing things in a field notebook, or whether you're putting a sensor in a stream and it's automatically recording data and metadata in a file. All data collection involves some kind of data entry. And so there's a lot of things that you can do in the data entry process to standardize your data and make sure that, I'm going to admit, Nick. And make sure that everybody can interpret your data. So think about using pre-designed forms or templates, because every time you go to the field, you take the form with you and you make sure that you write down all of the things that you're supposed to write down every time you go to the field. Think about using lists of valid values rather than free-form text. So if I send these 3 right here to the field and I tell them all to make observations of water temperature in the Logan River, one of them might write down temperature, one of them might write down T, one of them might write down temp. And then when they all come back and I try to put that data together, I have to figure out what those words mean. So if I standardize that before they go to the field, then that would be really helpful. Also, think about doing automated range checks. Things like pH must be between a value of 0 and 14. And if it's not, there's a problem there. If you're recording pH in the Logan River and you have a pH of 0, there's also a problem, right? 0 or 14 are really bad for fish. So keep that in mind. There's valid ranges of values for most things that we measure. And we want to make sure that the values that we're recording pass our sanity checks to keep our data integrity. Okay, number 6, automate analyses. Code creates reproducible results. Code is a record of the steps that you use to do your analysis. Code can be shared, which is a big deal, and code can be re-executed anytime. So if I make the initial investment to learn how to do some scripting, when I submit my paper for publication and it comes back 6 months later with reviews that say, I don't like the color of the plot in figure number 7, you can go to line 45 in your script, change the color, reproduce your plot, put it back in the figure and send it back to the reviewers and you're done. Otherwise, you have to go into Excel, click, 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 hope everything works great and hope you get the right result. Okay, so code can be re-executed at any time. It's a great record of what you've done. Number 7, consider storage media. So some of you may not even recognize some of these storage media. When I was in college, my undergrad, the 3.5-inch floppy, that was like, we did all our stuff on the 3.5-inch floppy. And I still remember the day when the 100 megabyte zip disk came out. And I thought to myself, I am never going to be able to fill this disk. And then the 250 megabyte zip disk came out and I was like, my life is complete. I will never fill this up. Well, it wasn't true. Okay, so now we've got our external hard drives, we've got our zip drives, and I've probably left one of those thumb drives in like every state in the country. Everywhere I go, I leave them everywhere. How many of you actually have a computer that can read a 3.5-inch floppy disk? Nobody in the room. How about a CD drive? Okay, so a couple of those. It's interesting, in 2009, as hard as it can believe, as it is to believe today, we can foresee the day when CD-ROMs might be difficult to read. So I, somewhere buried in one of my cabinets, have an external CD-ROM drive that I plug into my computer, but I almost never use it. So it's almost obsolete. And that's not that long ago. So consider the media. You don't want to strand your data on media that you can no longer read. And this brings us to backups. So all I'm going to say about backups is, number one, have a plan. Number two, stick to your plan. Number three, test your plan, preferably not when it's an emergency and you've had a failure. It's much easier to test your plan beforehand than when there's like a fire and something happens. And so in tribute to Betty Rosum, let's go back to Betty's 3-2-1 rule. So you should consider having 3 copies of your data, 2 types of storage media, can be cloud or hard drive or external drive, and 1 copy offsite. We had a fire at the water lab several years ago, and there were some really, really nervous people in the parking lot that day because the building was on fire and they weren't sure what was going to happen with their data and their instrumentation. So really strongly consider having a copy that's offsite. And then also consider your hard copy data, lab notebooks, research notes, field notes, like those are all irreplaceable artifacts too. And so if you lose those before you've had a chance to punch them into your computer, you may lose everything. Fires really do happen. So most of you are probably thinking, okay, I don't even recognize all those storage media you put up in the slide a couple slides ago. I just use the cloud, which is great. The cloud is great. It's convenient, it's accessible anywhere, it's cross-platform. We've got sharing, we can easily share links to files, folders, all that kind of stuff. It's relatively low cost for most of us. Most of the services that we're using are relatively free unless you have a ton of stuff. But have you ever read the privacy agreements associated with cloud storage providers? And are any of you working on data that are related to an institutional review board protocol with human subjects that have sensitive or personally identifiable information that you literally are not allowed to share in these platforms because you can't control who has access? So these are considerations that you have to think about with cloud storage. You get storage, but not much else. And file formats and semantics still matter, which brings us to number 8. Maintain effective metadata. Okay, so in the Borer paper, do not estimate your ability to forget details about a study. It's really easy to forget all of those details. And so metadata is a love note to the future. You may not go back and analyze your data until years later. And I don't know about you, but like I can't remember what I did yesterday. So trying to remember what I did 2 years ago when I'm looking at data 2 years later, it's a really hard thing to deal with. And so what is metadata? It's the who, what, where, when, why, and how, and a bunch of other considerations when it comes to data that may be needed for making sure that your data is findable, that it's accessible, and also making sure that people can actually interpret your data when they get it. Otherwise, if they're lucky, they get your data, but you might be getting a bunch of phone calls and emails asking you how to interpret your data. Okay, so if you maintain effective metadata that deals with all of these kinds of things, then your data are a lot more shareable. And this is important because just like everything else in the universe, information tends towards disorder, right? So at the time of data collection or publication, the information content of your data is highest, but it doesn't take very long before we start forgetting some of the specific details. And then a little bit more time, we start forgetting some of the generalized details. And then if we have an accident, like that's a precipitous drop, right? But people retire, people eventually pass away, and we may lose, a whole bunch of that institutional knowledge if we're not maintaining effective metadata. So imagine a world instead if we were able to curate our data in a reputable repository. Maybe we publish a paper and that uses the data and it increases the value of our data. Maybe somebody else comes back and annotates that data and they use it for another synthesis product. They write a paper about that and it increases the value of our data even more. And if we're careful about this path doesn't have to happen. Okay? Which brings me to number 9. So share and publish your data. You should be thinking from the beginning of your study about how you're going to share and publish your data, because it may be a requirement for you. You should be thinking about using a reputable repository that supports FAIR principles. I'll talk about those in just a second. You should probably be thinking about a repository that is specific to your discipline, because if you want people to find and access your data, it's a lot easier for them to find and access it if it's in a repository that they know about. You may choose a repository that matches your data type, the format, or metadata. And also, you want to be careful to make sure that when you put your data in a repository, it actually receives an identifier that's persistent, and you can actually cite that data in that repository. So FAIR stands for findable, accessible, interoperable, and reusable. And this is the short version. There's actually 14 guiding principles that go with FAIR. Findable means people can actually find it. Accessible means they can actually get their hands on it. Interoperable means they can actually do something with it. And then reusable means, can they actually do something because of the license or other restrictions you may have placed on the data. And the extent to which data meet these criteria determines whether they will be reused or not. And so when you're planning for data sharing, begin with the end in mind. Just like you should probably be thinking about your research papers and sitting down with your potential co-authors and deciding who's going to be a co-author and what's the order of authorship going to be and all of those kinds of things. You don't want to have really uncomfortable conversations at the end of a study when you've already produced the data in the paper about who's going to be an author and who's not going to be an author. So begin with the end in mind. Which products will be generated? Where and how will they be shared? Are there sensitivities around any of those data products? How will you organize the data files? And then who's going to be responsible for all of this? Okay, so where to get help? Great resources here at the library. Elle's put together some really nice resources that are online. If you need information about understanding metadata, organizing your data, meeting funding agency requirements, all of these things are available in tutorials online. And I know Elle is willing to talk to anybody on campus who is interested in, getting a little bit of help with data management. So here's my summary. Don't mess with the raw data. Use descriptive file names, file headers, archive data and non-proprietary data formats. Consider your data entry. Automate your analyses if you can. Consider your storage media, maintain effective metadata, and then share and publish your data. Steps 1 through 8 are really getting towards number 9, which is your end goal and the hopeful result. So with that, I will say, if there's any quick questions, I'm happy to answer any questions, but I think you're going to have an opportunity to shoot at a forum of knowledgeable people here too. So that's it.
Thank you so much. That was great. Were there any questions before we stepped over to the panel? Well, great. During the panel, we intend for that to be a little more conversational. So if you have questions, feel free to raise a hand. For those of you who are on Zoom, please type your questions into the chat so that Steph can read them for you. So I'd like to ask our panelists to come up and join us at this point. Oh, yeah. Thank you, Erica. So is that good? Do we need to turn on another light? Better? Okay. So hopefully you all have received the panelist bios via email for those of you on Zoom, but I'll briefly introduce everyone again. I meant to ask, do you prefer Willa or Professor Van Dyke? Okay. I was going to, since this is more conversational, we were going to go with first name basis. So this is Willa Van Dyke. She is an assistant professor of special education. Her research focuses on individual differences in reading development and effective reading instruction for struggling readers. Her data management experience is focused on human subject research and education, both observational and experimental, with an eye towards making data publicly available. Motassem has a master's degree from USU Department of Civil and Environmental Engineering and is currently working on his PhD in water resource management. During his master's, Motassem dealt with huge amounts of data related to exhaust emissions from vehicles, and right now he deals with lots of data related to watershed hydrology. So big data. Camilo is a postdoctoral researcher at USU, where he develops tools to manage, process, access, and analyze data. Camilo has worked with hydrological, climatological, water supply and demand, remote sensing, sensor data, and human subjects data. And then we have Amber, who has 10 years experience as a graduate research assistant and research staff at USU. Her work is centered around developing workflows for water-related data, ranging from environmental sensors to social science surveys. So the general questions that we brought to the panel were, what data management skills have you found to be essential for your projects? We'd also like to know if you have any tips, tricks, mentors who have been particularly helpful, courses or tools that have been transformative for your work with data and data management. And then if you have any nuggets of data horror stories that might be instructive for new researchers to learn from. So I will turn it over to you.
Everything that Jeff said, of like, oh, I have a story about that going wrong with somebody. So that was interesting to hear. Do you want to start with the horror stories?
If you've got,
I have a really good one. It's a short one, but
yeah, we're having problems with the mic still. So.
All right, so this is Willa. One of my favorite horror stories is when a very famous reading researcher gave me her Excel file of experimental research, and half of the rows were pink and the other half was yellow. And obviously, when you load this into a data analysis software, the colors go away. And so we're like, well, what were the colors? And she's like, oh, that's who was in the treatment or the control group. And so that information was now gone. We'd have to go back to the Excel file, make an extra column that said experimental status. And, you know, we indeed had several conversations back and forth, like, well, what does this mean? What does that mean? But yeah, so I think at the heart of that story is Excel is a great program to visualize for yourself what your data looks like, but it's not a great analysis tool to do the same things. So I would definitely caution against using Excel as your data entry or management system.
I've had some similar horror stories with receiving files from others and trying to make sense of their color coding in Excel, or there's various other ways that folks can format in Excel that may make a lot of sense to one person, but it's not very transferable. So I really concur with Willa's assessment there. And I think there are things to be learned there about how to present and share tabular data. And Jeff covered a lot of those details. And once you get in a habit of using those practices, it becomes easier to both receive from someone and to share with someone and to just make it part of your data workflow. And some of those I think are translatable to sharing code as well. And sometimes I get excited if I can get a script or a code from someone. So I'm like, oh, great, you've already done this. I don't need to reinvent it. But then I get their script and it, to me, is like uninterpretable. And so again, that's a place where adding comments, having README files, testing it for reproducibility, even with just having the files in the right directories and using the right relative paths can be really important. So that's just some general lessons learned from some personal horror stories. Another one I wanted to share was I've been in situations where I've needed to gather data from external sources like government agencies. And this is usually environmental data. And so in one case, I was looking for this high resolution time series data, like hourly data. And I downloaded it. I'm like, oh, great, this is what I need to run a model. And then I realized that this hourly data, it didn't match up with the reported daily data. And there were, I don't know, this is like, I think it was like snow accumulation, and there were negative values. And so I was just trying to interpret this, and there wasn't very much metadata about it. There wasn't information. So, you know, I emailed someone at the agency, and the response I got back was really interesting because they said, don't use that data, it's junk. Like, it gets put out, it's publicly available, it's distributed, you could use it, but actually you shouldn't because it's junk. So I learned a bit about their methods and their processes, and they were really focused on that daily data, right? And it was what had been reviewed and quality controlled. But the hourly data, they did not recommend using it. So for me, it was a lesson of like buyer beware. Know what's going on with data that you obtain from other sources. If you are seeing errors or interesting artifacts, be sure that sometimes you're looking for a scientific explanation of that, and it may just actually be a data artifact. And then by the same token, if you're the one producing the data, it's thinking about what you need to do to make sure that someone doesn't misinterpret.
Okay, so on this side. Okay. So in terms of a horror story, I don't know if it qualifies a horror story, but recently when I was working on my PhD, we just bought a data set of water use from a large study that was done here in the US. This was like a $2 million project, and they sell the data set on their website. We paid for it, we got it. When we saw it, it was in an Microsoft Access format that hasn't been used in years. So it took us 3 days, 3 persons to actually open the data set. And when we opened it, we realized the column names were abbreviations, there wasn't metadata. And even after contacting the researchers that collected this data, we were never able to use this data. So it's like a large study where they are still selling their data, but you cannot actually use it because not all the information is there. So that's one of the stories I want to share about data. We never ask our money back.
So it's not like a horror story, just like my personal experience. So I've done education in 3 different countries. I did bachelor in one country, then moved to another country, I did my master's, then I came here to the States. And in the previous countries, the one I had my undergraduate and my master's, the data is like a national of something very classified. So you cannot access data until you have to send letters, you have to meet higher ranking people in the organizations. So data was like something very scarce. And that's why you could wait months and weeks till you meet the person who will give the okay to give you the data, which was hard because for researchers, you didn't have all the time, right? You need to get to the data, start analyzing and produce results. So then I moved to the States and just everything is online. And I work with hydrology, so precipitation data online, stream flow online, ET online, everything is online. And this makes a huge difference, the data availability and sharing of data. And we're just talking about raw data, not like produced results and processed data. So it makes a difference, huge difference, because with no data, you cannot do anything. You just stay and wait. When you come to the stage with like this mentality where the data is shared online you didn't have to wait for long times, you didn't have to ask for permissions, you could just start right away. You arrive to the States or you start your spring semester or fall semester, the first day, you have full access to most of the data you need for your project, and it makes a huge difference. And it might also help now to start sharing the processed results and outcomes of the studies, because it makes the things easier for the people gonna work in the same project. Like for some courses now, we use the same projects done by the students from previous years. It makes everything easier when we start. Instead of starting from scratch, you could just start building on what those people did, and it's just, again, make a huge difference. So I like it here. I think it's a good way to share and make everything is public instead of just keep it locked.
Oh, you want to, I have another horror story about like data management. You know, like when I was working with rainfall data in other places, back in the days when this data was manually collected, so a person was going every morning and reading the pluviometer to see how much water was there, to see if there had been rainfall or not. So sometimes the pluviometer couldn't be read in every day. So it happened 2 or 3 days. So you would have a daily value that was accumulated from 3 days. So you have days when there is no rainfall, which is 0, days when there is no data, because for some reason you have no data, and days when the data is rolled up to the following days. So the way and this happens with all meteorological records in a lot of places. When you're going to use that data, you need to know what code is being used to indicate what is a missing value, what is a value that's accumulated in the next value, and what is the value that actually has the accumulation from the previous day. And these codes and the way that this is managed is done differently by different agencies in different places. So I think standardizing and thinking about how you're going to manage your data, making public the metadata and the procedures that you use can help like avoid a lot of issues with data.
Yeah, I do want to advocate for working with like a research librarian, or if in your department there is a data manager. I did my postdoc at Florida State University, and our center, the Center for Reading Research, had its own data manager person who worked with the researchers to design data entry systems, management systems, and that was great. And we had some great research librarians too. To help with that. So I want to advocate that, to think about how you're going to do this before you collect your data, instead of what. So part of my job is I'm an applied methodologist. So people send me their data and say, hey, run these analyses. This is what we want to know. And I'm like, okay. And sometimes they say, but you'll need to clean the data a little bit before you start. Okay, and I work with little people data that often come from schools. So I think that's a little different with if you work with like sensor data, you know, this is the sensor, but there was a data set with, I think we had 8,000 kids in there. The data came from the schools, but the research team hadn't thought about how to combine all the data yet. And so I have a bunch of Excel files with student names, but they don't have a specific project ID yet. So I had to go manually through all the files to assign each student an ID. And I thought, oh, that's easy, right? I just merge a bunch of things. But then there's this student in first grade, and his name was Mario Lopez. And that was a male. Mario Lopez didn't exist in second grade, but there was a Maria Lopez. I was like, well, I don't know. The common names could be. And then in third grade, we had Mario Lopez again. I was like, well, maybe this was actually the same student. But it took me about 3 weeks to go through the whole thing to make sure that every student had a unique ID and wasn't duplicated, or if the same student wasn't in there twice with a different name, or if I gave the same ID to different students, because sometimes people have the same names, right? It happens. There's actually another Willa van Dijk in the Netherlands. We also look the same, which is not surprising because I'm very Dutch. But that takes your data manager three. That was just me. And this was my somebody gave this data to me for my dissertation. I was like, thanks, I'll fix this for you. But these are things that you can avoid by thinking about how are you going to collect your data and manage this in a system before you get data from 500 schools.
So in a previous role, I worked as a data manager for a multidisciplinary and multi-institutional project. And it was a water related project, but we were not only collecting like physical data sets, but also social science data sets. And what I saw in that role, I mean, that's where some of my horror stories are from, because people would send me spreadsheets like, oh, here's my data, like, let's make it public. And like Camilo mentioned abbreviations, and that was something I was just like a broken record, telling participants, like, you need to define your abbreviations, even if it's a standard in your, you know, very niche field. It's just like, that's a practice that we all need to be doing. But I lost my train of thought. Just that the researcher projects that were most fluid and successful with their data management were the ones that were planning for it from the get-go, and addressing some of those questions that Jeff had posted, beginning with the end in mind. Who will do this? What data sets or variables will be generated? And, you know, maybe even like Willa was mentioning, what should those files look like? Who's going to verify them? And those steps are really different for different data collection types, for different domains. But I think that not leaving it until the end when it's an afterthought is crucial. A couple other things I thought of. One is that there's a lot of, like Elle mentioned, what are tips or tricks or tools? And in our field, there's an online repository that many of us use regularly. And so that's become kind of a standard where, oh, I can post my data there. I can cite that in my publication that I develop. I can, you know, and there's certain levels of metadata that are associated with it. And so becoming familiar with those types of resources in your specific domain or field, interacting with data managers or librarians who are knowledgeable about that, I think is really key.
All right, thank you. All right, so question in chat reads, when working with human subjects data, what are your recommendations for data storage and sharing, particularly when they're sensitive data? What are your tips, tricks, or horror stories with this?
That's a great question, because it gets into, from the discussions that I've been a party to, it sounds like Box is HIPAA compliant, but you know, you brought up that it was more problematic for sensitive data. So I would really love to hear from, you know, the two of you that work with human subjects data about how you do it.
I think when I did my graduate work, that the University of Florida had a Dropbox account that was specific to the university, and that was HIPAA compliant. So I had my own Dropbox account and then the university account, and you could store data on the university account that was HIPAA compliant. And I'm assuming at USU that is the same with the USU Box account, but I don't actually know. I don't collect my own data, so to me it's not a problem because people give me, usually, if they do it right, de-identified data. So that is something to think about when you work with human subjects and you're preparing data to be shared, is the HIPAA data should not be in data that you publish open access to other people. And then that's not the only way you could identify people in your data set. So I'm in special education. We have a lot of different disabilities. So if I have, for example, data on all the students in Logan with disabilities, and there is one African American student who has autism, and there's really just one African American student with autism. And I don't know if this is true, I'm making it up, but even if I don't put their birthday or their social security number, you could still identify this person because of the combination of these two characteristics. So it's really important to work on de-identification procedures beyond just taking out their date of birth or their social or their phone number, just to make sure that people who get the data can't re-identify. I think there was a really famous study on, I'm going to say it was cancer patients, where it was a de-identified data set, but with only 3 or 4 variables, they were able to re-identify about 60% of that data set. So it's a little scary. But so that's a tip before you share your data. And there's a lot of human subject or social science specific data repositories where you can do your data. So I worked on LD base, which is individual differences in learning data repository, but there's ICPSR. If you have qualitative data, there's it's at Syracuse. I'm blanking on the name now, but there's definitely several different domain specific repositories for social science or educational research too. Did I hit like all of the, yes, great.
I was just going to make a quick comment that for the social science projects that I've been involved with, we've had IRB approval for storing our data in Box, and nothing that I've been involved with has related to HIPAA at all, but Box has been approved as being the most secure place. And again, I think that IRB process is actually really beneficial because it helps you think through what data will be produced, what pieces of that might be sensitive, how might we need to de-identify them, and then what will the end disposition be on those data.
It ties into some of our earlier questions, but where did you learn how to do your data processing and data management? Was it something that you took specific courses in? Did you learn it from your advisors? Is it something that you picked up on the job from other graduate students or postdocs? Is it a little bit of all of the above?
For me, it's a little bit of all of the above. My advisor actually didn't do a ton of specific research. So I worked a lot with other people who had a lot of data, and then you learn a little bit about managing. And then my postdoc was for LD-based data repository. So I learned a ton about managing data and publishing. And so both of my advisors there are data management heroes who have way more horror stories than I did. And then I do want to mention that my dad when I was young, so in like the mid 80s, had this book on Excel that I decided just to go through when I was 10 because that was fun. So I think it's kind of a, Jeff mentioned he's a data geek, and I'm like, well, yeah, so there was sort of an interest all along that got sparked along the way.
For me, I think it started when, as part of my master's project, I was involved in collecting all of these data. And then it was sort of like, well, we have to manage all of these data somehow. And so it moved from an emphasis being on the science and the data analyses to, sort of that meta level of what do we do with these data? What are our workflows and how do we automate that? And in that process, I think I've just sort of had the kind of all of the above. Also, I do think there are some really more so now than maybe 10 years ago when I was sort of starting in on this path, but there are a lot more resources available online for training and learning. like generating and creating reproducible code. Like you can take software carpentry classes, or there's a lot of sort of intro to R or Python coding. And all of that, I think, is just really helpful to put you in the mindset of how to make, because that's what a script is, make this function, make this algorithm, make it reproducible. And then, you know, some of the resources that Jeff shared and the website that talks about FAIR data principles, there's some really useful examples there as well.
So I think for me, it's also like a little bit of everything. Of course, I did my PhD with Jeff, so that helped me a lot. And he makes sure that you have like a resource online and the code that reproduce your results before we submit papers for publication. But something that, I mean, beyond what have been mentioned, it's something that helps a lot is just think about what data you're going to collect, what metadata you're going to need, how you're going to store it. Like think about the data before you start working on this. I know that has been mentioned, but that's really helpful. And also like other things that have helped me improve my data management skills is like coding, like it has been mentioned, working with codes and databasing is also important, I would say. And sometimes it's just knowing what resources are out there, because sometimes you have your data, you have everything, but you don't know where you can publish it or things like that. So sometimes it's just having information and knowing how to use it.
So I think most of the knowledge I get about data from courses. Right now I'm taking the hydroinformatics course with Dr. Horosboro, and covers lots of aspects of data management. And because a huge part of the project I'm working on deals with different type of data and huge amount of data, we had, like my supervisor and I, like we all sat and just learn from him things about how to manage the data the way we want the project to be on. So yeah, just like courses mainly, supervisor, sometimes just self-learning, this kind of stuff.
So one practice that's been really helpful for me is, because I've looked at so many data sets, now when I'm producing something, I'm thinking, oh, what if someone is looking at this? And a really useful practice is getting a colleague to review your data set. And this is a colleague who's not working on the same project, who's not working on the same data, but is, you know, can understand the metadata and the instructions maybe that you give. So like Camilo and I are colleagues, but we're not working on the same project. Camilo's submitting a paper for publication. So he sends me his code repository and his data set and says, hey, can you regenerate these results? And so then I can look through his code, I can run it, see if it works. If it gives me any errors, I can look through his data files and say, what does this even mean? Or say it looks great. And so that's a practice that's really benefited us as far as reproducibility is concerned.
Well, great. So much. Were there any other questions that folks had?
So for some research, I'm making a simulation, which is a bunch of computer code. What do you feel are the best characteristics and qualities to have in that code so that other scientists are able to use what I'm making effectively?
You're making faces, Jeff. Do you want to comment?
I'm happy to comment. They're in the hot seat, so maybe we should let them comment first.
I mean, my short answer is comments and instructions more than anything. And I think you can be verbose and no one will complain if your comments are very verbose about that. So
You may say.
So yeah, like, and I think like comments and instruction are sometimes not for other people, and it's sometimes not 6 months when you get reviews for your paper. It can be next week that you're trying to do something else and you don't remember what a line of code that you wrote does. And I think like, yeah, so I think it's important. Comments are important not just for reproducibility, but also for ourselves, for like, so we don't forget what we did.
It's fun to look back. Or I think it's fun to look back on code I wrote like 5 years ago, and I'm like, I have no idea what this all means. I had 0 comments, and as I'm moving forward in my career, I'm getting better at annotating my own code in a way that I think future Willa will appreciate. So always think about your future self and how would they feel if they read something or saw something.
I like to think about it as a gift to your future self.
One other thing I was going to say was a lot of times with code, you need to document your code packages and versions. And there's different ways to do that. Sometimes it's just, I used this version. If you're using Python, you can wrap that into a virtual environment. With other coding languages, there will be other approaches, but you can have major issues with versioning if you're using something from 5 years ago.
So it's something also find useful, like to use the control version thing instead of having different copies of the same like Python file. As Dr. Jeff showed, final. Finally, this one you could just use version control instead of having different files. You could just have one file but different versions of the code, and you could just access any one of them whenever you want. Just might be helpful as well. Thank you.
So were there any final comments before we wrap up? Have a couple more questions from Erica. No, do you want to have the last word, Jeff? Or we?
You did a great job.
Yeah, thank you so much. I really appreciate all of your perspectives. And I hope that we can get your permission to share your contact information to continue the conversation going forward with students and such. So keep an eye on your inbox. We'll send an email with that information as we close up. So, and I'm going to turn it over to Erica.
Thank you. And I have a microphone that works this time, so that's really exciting.
So we're going to go back to the Mentimeter. Last.
Yep. So we're just going to hop back on Mentimeter. So if you kept it open and you're already in there, you're all set. If you haven't joined us in Mentimeter yet, you can get there by going to menti.com. That's MENTI.com and enter the numbers 81488070. Anything you answer in here is anonymous. We can't see who's responding and no one else can either. So feel free to share your thoughts. Hopefully you learned something exciting today. I can see we've got a few people in there. I'll just give you one more minute to join. So again, that's MENTI.com and the number's 81488070. All right, so our first wrap-up question is, what's one thing you learned today? I'm so excited to see what some of these responses are going to be. Fair, yes, fair data principles, very important. You are not alone. Absolutely, you are not. What metadata is very important, yes. Sharing data is good. These are great things to take away from this session today. I'm so excited to see these responses. Yes, CSV is a good file type. Please don't work with PDFs. Don't do it. Yes, give gifts to your future self. All right. Now, how confident are you in your understanding of data management? Now, our previous answer to this question, our average was about 3. So I'm hoping it's, oh, it is higher now. This is looking good. I'm so glad you guys have taken some stuff away from the session today. Yep, we're almost at 4. I'm going to round up. I'm rounding up. We're at a 4 now. Yep. All right, who will you ask if you have questions about data management? And I'm sure you are still going to have more questions after today. So who are you going to ask? L, yeah, or L is number 1. I like how the font is doing this. Erica, yeah, absolutely. You could ask me, data librarian, that is L. Jeff, you're on the spot. People are going to be coming to you with questions. Google, yep. A supervisor, also a good person to talk to. The library in general, yes, we have lots of resources. Absolutely fantastic. I'm glad you guys know where you're going to go to ask your questions. All right, and last, that was it. That was my last question. But if you do have any more questions after today, you can visit our data management website. You can email researchdata@usu.edu, or you can email L directly. All those email addresses are up there, and you can find them on our website as well.
I also wanted to thank everyone for coming and put another plug. We do a lot of work around data publication and getting data ready to go out for a publication or consultations with data management plans. And if you have any kinds of questions in that regard, please reach out to us. We're always happy to help. And if you have any other kinds of questions, please reach out to us. We'll help move things forward, even if it's not something we do in-house. So, and I also wanted to encourage Erica to put in a plug for what you are likely to talk to her about. Well, like if they're working on their,
Something specific.
well, I was thinking about ETDs.
Yes, ETDs. If you do have any questions about your thesis or dissertation, you can reach out to me. It's erica.finch@usu.edu. I'd be happy to help you out.
Thanks so much.
And thanks again to our panelists.